Welcome back to HFY Space Stories. Today's topic ventures into the fascinating intersection of neurotechnology and space
Bridging the
exploration.
void, Neuralink
How
establishes an
Neuralink's
instantaneous
brain-computer
connection,
interface
transforming
technology
isolated
could
explorers.
revolutionize human space travel and transform astronauts into enhanced explorers of the cosmos. Imagine an astronaut on Mars who can communicate telepathically with mission control on Earth, access vast databases of information with a thought, or control complex spacecraft systems using only their mind. This isn't science fiction. It's the potential future that Neuralink technology promises for space exploration. Neuralink, founded by Elon Musk in 2016, has developed ultra-high bandwidth brain-machine interfaces. The system consists of flexible electrode threads thinner than human hair, inserted into the brain by a precision surgical robot. These threads can monitor and stimulate neural activity with unprecedented accuracy. But why is this revolutionary for space travel? Let's examine the challenges astronauts face and how neural enhancement could solve them. First, communication delays. Mars is 4 to 24 light minutes away from Earth, depending on orbital positions. This means real-time communication is impossible. However, with Neuralink enhanced memory and processing capabilities, astronauts could download entire mission protocols, technical manuals, and emergency procedures directly into their neural networks before departure. The human brain typically processes information at about 10 bits per second through typing or speech. Neuralink aims to achieve bandwidths of 1 million bits per second, a 100,000 times improvement. This means downloading a complete spacecraft manual could happen in seconds rather than months of study. Consider the cognitive challenges of long-duration spaceflight. Current astronauts report space fog, reduced cognitive function due to cosmic radiation, isolation, and stress. Neuralink could potentially compensate by enhancing working memory, processing speed, and decision-making capabilities. The technology enables direct neural control of spacecraft systems. Instead of complex physical controls, astronauts could interface directly with their vessel's computer systems. This is particularly valuable in emergencies where traditional controls might be damaged or inaccessible. Mental health is a critical concern for Mars missions. 6 to 9 months of travel in a confined space, followed by years on an alien world, creates unprecedented psychological challenges. Neuralink could provide real-time monitoring of mental states and potentially deliver targeted interventions, mood regulation, stress reduction, even simulated experiences of Earth environments. The learning capabilities are extraordinary. Traditional astronaut training takes years to master. With neural interfaces, complex skills could potentially be downloaded directly. Imagine instantly acquiring expertise in Martian geology, advanced medical procedures, or alien technology analysis. However, the applications extend beyond individual enhancement. Multiple Neuralink-equipped crew members could form a neural network, sharing information, emotions, and decision-making processes in real time. This collective intelligence could solve complex problems faster and more effectively than isolated individuals. For planetary exploration, the advantages multiply. Neuralink could interface with robotic systems, allowing astronauts to inhabit rovers or drones for remote exploration while remaining safely in base habitats. The sensory experience would be direct and immediate, seeing through robotic eyes, feeling through robotic sensors. The technology also addresses medical emergencies. Space missions cannot carry specialized doctors for every possible medical situation. But with Neuralink, any crew member could access advanced medical knowledge and even receive real-time guidance from Earth-based specialists, with the neural interface compensating for communication delays by predictively loading relevant information. Current progress is remarkable. Neuralink has successfully demonstrated thought-controlled computer interaction in paralyzed patients. Participants can type, play games, and control devices using only their thoughts. The technology is approaching the resolution needed for more complex applications. Safety considerations are paramount. Brain surgery, even with robotic precision, carries risks. Long-term effects of neural implants in the space environment with increased radiation and microgravity are unknown. Cybersecurity becomes literal brain security, requiring unprecedented protection against hacking or malicious interference. Ethical questions abound. Should space exploration enhancement be mandatory for Mars astronauts? What happens to enhanced individuals when they return to Earth? How do we prevent creating a class of neural elites versus unenhanced humans? The timeline suggests we might see Neuralink-enhanced astronauts within the next decade. The technology is advancing rapidly, and space agencies are actively researching brain-computer interfaces for future missions. But the ultimate vision extends beyond enhancement. It's about human adaptation for permanent space habitation. Future spaceborne generations might naturally integrate with AI systems, making Neuralink not just an advantage but a necessity for surviving and thriving in the hostile environment beyond Earth. Neuralink represents a fundamental shift in human capability, not just for space exploration, but for our evolution as a species. As we prepare to become a multi-planetary civilization, technologies like this might determine not just our success in space, but our very definition of what it means to be human. Subscribe to HFY Space Stories to explore more incredible technologies that are reshaping humanity's future in space. Ring that notification bell so you never miss our deep dives into the amazing innovations taking us to the stars.